So, just to kind of reiterate something I said before, I am not here to grade solutions manuals. I'm here to grade your work. So if you continue to give me copied stuff, I'm going to eventually just say, don't give me anything else. You got a 0 for the homework because I'm not here to grade a solutions manual, right? Is everybody with me? Not everybody's doing that, but a decent chunk of people are doing that. So just be careful. Yeah, okay. Any questions from the quiz? Everybody got their quiz back? Any questions from the quiz? Anything not make sense? Why you missed it? Or you don't understand what it was supposed to be? All right, you guys seem beaten down this morning. I'm sorry. So just to show you, so here's the grade distribution, right? This little symbol here, you read it as X bar. We're going to talk about it today. And this little symbol is standard deviation, right? This is for samples. So the average was below 70, but if you take out the 2 lowest grades, it goes up to a 75, right? Just to kind of give you an idea. Because I do curve grades if I think that needs to happen, but considering that, I just decided not to curve it. This is the number that represents the spread of the data, right? So this data was really spread out. Normally for a quiz, it's 14 or 15 or something. So 22 means it was really spread out, right? Okay. You guys with me a little bit? And just to remind you, each quiz will end up counting as roughly 3% of your grade. So a quiz by itself cannot hurt you, right? And I might have said this before, but the quizzes together can gang up on you, right? But you can, just to remind you, you can make corrections directly to the quiz and give points back. If you make corrections to the quiz and you do better on the test, your quiz grade would go up again. So let's run through a scenario real quick. Stay with me, guys. If you make it a 60 on the quiz and you get all the corrections done and right, you missed 40 points divided by 4, you can get 10 points back. You get up to a 70, yes? Which is just barely passing, but it's better than you were, but still kind of. Then let's say on the test you get a 77. The quiz grade becomes a 77. Say on the test you get a 93. Quiz grade becomes a 93. Yes? So roll back. Let's go to an alternate timeline. If you did the corrections and went from a 60 to a 65, you got half the points, yes? So then whatever you make on the test, if it's higher, I will average that halfway. So the number of points you can get if you make the test higher grade is commensurate with how many points you got back on the corrections. If that was way too much shit this early on a Tuesday morning, just do the corrections. Everything's better, right? And when you do the corrections, get help. Don't rely on the person that made the mistakes in the first place, right? All right. Maybe. And again, I act as a tutor. You can come see me and say, Jeff, I'm not turning this in. Can you tell me if this looks good? And I will tell you, good, you didn't do this one right. You need to redo this one. And then I'll even explain to you. If you ask me, hey, can you explain? I'll explain to you what the point is, yeah? It's crazy. Okay. All right. So your grade doesn't become set in stone very early. It's dynamic for a while. Okay. So no questions from the quiz or questions from homework, maybe? Yes.
It's for question 25 on homework 2.3.
25. Oh yeah. Okay, good. All right, I'll look. So this problem, there's 2.325. This one says Jesse was ranked 37th in his class of 180. So there's 180 total students. And he's ranked 37th. Just by that token, is that relatively good or relatively bad? What's the best thing to be ranked? Holy shit. 37th is not first, but there's 180 people, so rank 37, is that relatively good? Yes? Okay. Were there more people who are ranked above him or below him? So shouldn't his percentile be high? Because there's a larger percent below him, 11. So just operate straight from the definition of percentile. What does a percentile mean? So if I say somebody is in the 70th percentile, what does that mean? 70% of everything else was below that, right? Can anyone tell me what percent of, how many people are ranked below Jesse? What would you do to figure out how many people are ranked below Jesse? Yeah, 180 minus 37, roughly, right? Can you make that into a percentage of everybody? Okay, so I'll stop. So if you just go back to the definition of percentile. Now, the book has a very complicated formula for percentiles, which doesn't make sense. I mean, for a small sample, it'll be different, but percentiles are not as accurate for small samples. For a big-ass sample, their crazy-ass formula is exactly the same as what I just said to do. Right? But if you want to, you can use their formula, that's fine. You don't need to. It's much more basic than that. Percentile is just the percentage that's below some set score. Okay. You guys semi with me? No? Does that help? Is that better, Sophia?
Yeah.
Yeah, okay.
I have a question, sorry.
Yeah, don't apologize for questions ever.
2.4, question 90.
Question 90?
Yes.
Okay. Oh, yeah, okay, beautiful. So number 90 gives you data in a different way than we're used to. Number of movies, well, not a totally different way. We've created frequency tables before. 0, 1, 2, 3, 4, 5, 9, 6, 4, 1. And they want to know, they want you to create a box plot, right? Can somebody remind me what it is I need to figure out before I can construct a box plot? What's the name of that set of things I got to figure out to create a box plot?
Your quarters.
Yeah, the quarters and the high and the low.
Yeah, and what is that all together? It's called the 5-number summary. I love it, right? Low and high is easy, even like this. All right, now let me ask you this. What is my data up here? Can anyone tell me what the data is?
The numbers.
Oh, yeah, but there's two sets of numbers.
But like, what do you mean?
Be more specific.
Oh, yeah.
Data is the answer to the question asked. What question was asked?
How many movies?
How many movies? And I don't remember this. How many movies have you watched? The previous week. Wow, who's got time to watch 4 movies? Okay, sorry. One person. So how many movies did you watch the previous week? You with me? That's the question. So the data is right here. 0, 1, 2, 3, 4. Yes? What the hell does 5 mean?
How many people watched your movie?
5 people said 0. You with me? Now, you could do this. If you just had a list of the data, what would it look like then? 0? Come on, you can do it. What would the actual raw data look like? Don't say 1.
5 zeros.
Yeah, it'd be 0, 0, 0, 0, 0. 1. No, so screw that. I'm not going to do that. That's silly. Isn't this in order? There's just 5 of these, and there's 9 of these. So let's do one example. High, low, easy shit. What's the highest?
4.
Holy crap. What's the lowest?
0.
Holy shit. Okay. How do I do Q1? Can somebody remind me what the work is for Q1? There's 2 steps. What's Q1 mean?
25th percentile.
25th percentile. So what's the first step for it? What's the first step I do?
Find the 25th percentile.
True. Okay, that's the whole thing. That's not even a step.
Okay.
So where would the 25th percentile be if I have the whole list?
Oh, yeah. It's count
It would be how much of the way into the list?
Quartile.
25% of the way in. Does that make sense? I want to leave 25% of the numbers below me, so I'm going to go 25% of the way into the list, yes? Can anyone tell me how long the list is? If I was going to continue doing what I started doing here, how long would it be?
25.
There you go, 5, 10, 25, right? I have 5, 10, 25, right? So there's 25. So for Q1, I've got to do 25% of 25. Because again, percentiles, quartiles, I do a percentage of how much data I've got, right? I lock it. So what's 0.25 times 25? 6.25. Does anyone remember what to do if I get a decimal number?
Rounded.
Go to the seventh. It's kind of nice when you get a decimal number, because now watch this. Don't say anything yet. Don't say anything. What's the seventh number? Don't say it yet. If you know it, don't say it. Just think about this. What is the seventh number? Okay, tell me.
1.
Yes. Right? The first 5 numbers are 0, so the 6th and the 7th numbers are 1. Are you guys with me? Does that make sense? That's how you have to parse this out. Don't write 5 zeros and 9 ones. You could, but do you see how you don't need to? What is the 15th number? What is the 15th number? How many numbers are there if I go this far? 14. So what's the 15th number? 2. You got to go 5 zeros, 9 ones, 14. So the 15th number must be 2. Do you guys see that? You don't have to write the whole stupid list out. So when you do this work, it'll tell you which number to go get. And then you just have to realize, I can just count my way through this shit. I don't have to write all the stupid data points. Maybe? You guys look very excited. Okay. Is that good? Okay. It's a great question, because we're not used to just getting data like this. We're used to getting the data and then making this. Maybe. All right. Anything else from homework? I just want to point something out. Do you guys appreciate that she asked those questions? Right? Do you guys take notes if you haven't done this problem yet? Like, oh shit, now I kind of know what to do. I want everybody to realize, if you have a question, don't look at it as if, nobody else has questions. No. Look at it as if, I could be people's hero for asking this freaking question because they don't feel comfortable to ask it. Do I make sense? So just ask. Don't hold back, right? Okay. Where am I at? There I am. Good. Okay. So if there's no more questions, any more questions? When are the quiz corrections due?
The day of the next quiz, right?
The day of the next test.
Test. Oh.
Yes. Right. When is the next quiz?
This Thursday.
Oh shit. My little Valentine's gift to you is the promise of a quiz on Thursday. And trust me, I don't know if you guys know this. I know some of you guys are relatively new to college, but you want more grades. My God, you want grades. I had a class once where the only grade was the oral final examination. He put us each in our own rooms, gave us a question, and then said, I'll be back, work on that. And I'm like, oh shit. and there was nothing before that. All the homework we did didn't count for shit. It was all that final exam. Does that sound like a great, do you think I was a little stressed out? My friend in the room next to me had a nervous breakdown. She started crying, and I'm like, what the shit? And he's like, just keep working, we're gonna help her. Oh my God. Anyway, sorry. So you want more grades. Okay. So just to be clear about what this is like frequency distribution, histogram, stem and leaf plot, right? And then this one is percentiles and quartiles. Not box plots yet, but just percentiles and quartiles, right? So we did a worksheet last time, just looking at percentiles and quartiles. And then we made a box plot, but that won't be on this next quiz yet. Okay. All right. So, the last thing we did, I think, was to basically finish off box plots and stuff like that, if I'm remembering correctly. There's one thing I didn't talk about yet, related to percentiles and quartiles. So let's see. Let's do a really quick problem here. I'm gonna make up some. I'm gonna do my favorite thing. I'm gonna make up some data. All right, let's go. Let's see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's do one more. 14. Okay, there. All right, so I want us to do. Let's do a quick little review. The 5-number summary. If I ask for that, I want the lowest data point, the highest, and what do I want in the middle here?
That's 3 quartiles.
Yeah, Q1, Q2, Q3. Okay. One thing that's really nice, of course, about the list I gave you is it's already in order. You know, in a quiz or a test, I'm gonna just give you data. So you can just do the most basic thing, put it in the list and sort it, right, in the calculator. So obviously the low is 15, the high is 49. Can you guys kind of help me? We just did one like this, so how do I figure out the first quartile? Yeah, how many data points are there? Yeah. So N is 14. N is the size of the group you're looking at. So to figure out the first quartile, what do I do exactly? First quartile is also known as the 25th percentile.
So 425 times.
Yes, I like it. So I want to do 25% of 14, which you can do 0.25 times 14, but I kind of like 25% is 1/4 of something. Is that cool? Then I can reduce that to 7/2, which is 3.5. And again, when I get a decimal there, what do I do? Round up. So what is Q1? 25. I love it. Q2, same. So let's go ahead and figure out Q2 and Q3. I'll just wait. I'll wait. Let me give myself some more room here. Wow. Sounds like I unsheathed the sword.
Dude, I was gonna say that right now.
You better do this right. This is gonna have repercussions. Is that rain or something?
That's rain, yeah.
Okay.
We're located like right by where the entrance of the school is, so obviously we'll hear a lot of cars, you know.
True. I'm pretty sure that was rain. that just
Yeah,
started
it's
happening.
raining and what's it called?
Splash.
Yeah.
You have to just, gotta let this make sense. Don't look at this as, oh, I gotta remember this shit. Why does this make sense? Q2 is the second quartile, is 50%. So doesn't it make sense that I wanna go 50% of the way into the list? That's where I wanna go. And that's why the first step is 50% of 14. Because then I definitely have half of the data below me if I do that. So what do you guys get? What is 50% of 14? 7. So what do I do if it's a whole number? That's the one thing that kind of sucks to get. I gotta average it with the eighth. 7 1/8 average, right? Bless you.
Thank you.
Green, I'm sorry, you're not cut. I want it to be multicolor here. 7th and 8th. What are the 7th and 8th numbers? 1, 2,
7,
4, 5,
27.
6, 7, 8. Oh, that's nice. So what's the average of 27?
27.
Holy shit. Okay. You can do it, Jeff. There you go, buddy. Just remind you, who remembers the shortcut for Q3?
25 backwards.
Yeah, if I do 4 steps from the top to get to the 25th percentile, I can do 4 steps from the bottom, 1, 2, 3, 4, to get to the 75th percentile. Or you could do 75% of 14, round it up, take the number, you'll still get that same answer. A little shortcut. Okay, I like it. Make a box plot out of that for me real quick. Yes.
So can you repeat what you just said about the shortcut?
Yeah. So if 25% of the way in is 4 steps in, right? 75th percentile means 25% of the way from the end. So I know 25% of the way is 4 steps, so I can just do 1, 2, 3, 4 steps. Or again, you could just do it 75% of 14, blah, blah, blah. It'll still come out to be the same answer. It's just a little shortcut. Yeah.
Thanks.
You're welcome. Anytime you've got to make a scale, the only consideration about the data is how far down and how far up. I don't care about the numbers themselves. I just have to give them all a place to go. Because every step I take needs to be consistent. It shouldn't be based on these. So if I start at 15, I need to get up to what?
50.
50. So who's got a scale I can go?
Well, 15 to 50. You need to go up to 49. That's 7.
Yeah, we just need a place for it. I could have started at 10. We just have to have a place for everything to go. So let's see, if I go 5s, let's see. Let me go 10s. Well, let's go 5s. 15, 20, 25, 30, 35, 40, 45, 50. Okay, that's pretty good, Jeff. You could have done better. Didn't have to smoosh it all in there too much. 20, 25, 30, 35, 40. Now you did it too big. 45, 50. Okay. All right, so now every data point has a home, has a place to go, right? So this is where you just draw a line, low, Q1, Q2, Q3, high. Now, let me ask you, if you thought there was going to be outliers to this data, right? Let me make sure. Yeah, okay, good. If you thought there was going to be outliers to this data, what do you think? So the word outlier, I haven't said that yet. What does outlier mean? If something's an outlier.
Isn't it like if it's further than 2?
All right, well now that's a really technical definition. Just a general definition. Outlier would be very different from where most of the data is, right? So then you can start talking about, that seems to be a distance idea. It's got to be far away from where most of the data is. So what would be a really good candidate for possibly being an outlier?
The highs and lows.
Yeah. Normally you would go to these. Which one of these is more likely to be an outlier?
49.
Yeah, because isn't most of the data here? And 49 is much further away from that than 15 is. Okay, so I'm not going to be overly concerned, but there is one idea we do have to know, and it kind of builds up to this. There's something called the interquartile range. Oh shit. So what was the range? The range of data was something minus something. Do you guys remember? It was what we did to create class width. High minus low. That was the range. Sort of makes sense. How far does my data range? I'll just look at the highest and the lowest, right? That's how far the data ranges. So the range is high minus low. The interquartile range is Q3 minus Q1. Interquartile range. So that's going to be Q3 minus Q1. So for this data, what is the IQR, the ICR? Q3 minus Q1? 9, right? Okay. So here's the idea. And this is not a huge idea. I'm not going to really harp on this that much. But there might be a homework problem that talks about this. If you do Q1 minus 1.5 of these. So if I start at Q1 and I go down 1.5 steps, 1.5 of those, that'll give me an idea of where the outliers might start. So let's just try to do this. Q1 is 25 minus 1.5 times 9. Can somebody do that for me? Yes.
11.5.
Yeah. And then if I do, so that's the lowest. So are there any, so if I go down this many steps, I get to 11.5. So 15 is not an outlier because it's inside of that. So this is a technical definition of what an outlier is. So obviously if I'm in a room and everybody is in their 20s except for one guy in the back who's 87. According to ages, that guy's an outlier. He's very different from the rest of the group. Right? Or I could even just say me, 50-year-old dude. I'm an outlier for a lot of my classes. If I do, so this is the lower step. So if I go Q3 plus 1.5 steps, let me do it more generally. Q3 plus 1.5 IQRs. So if I do 34 plus 1.5 times 9.
47.
Yes, 47.5. So anything outside of 11.5 to 47.5 are outliers. And the only thing that's outside of that is 49. So technically, 49 is an outlier because it's so different from where the rest of the data is. Okay, so this idea of outlier is going to come up again. There's a more general, kind of more useful way we determine outliers, but that's based on a normal distribution. This is for any freaking distribution. This will work. Okay. All right, maybe. So you can imagine, so if you were in a nuclear power plant, can you imagine there's probably some dials that have green, yellow, red? Can you imagine, right? Green, yellow, red. Bryan Cranston's running around. Oh my God, Godzilla. So if it starts to get into the unusual territory, if it starts to become an outlier, the whole green is like, okay, it's got some wiggle room. That means everything's fine, just normal variations. But the minute it goes into the yellow, it's getting out here. And then the red is out there. That's where you better get off your ass. Me, the minute it's in the green but kind of going towards the yellow, I would be up off my ass, stop eating my donut, and start seeing what's going on. Right? Okay. Just as one real life example of how this could be used. All right, so that was a little review with a little bit extra information. Okay, so IQR just means interquartile range. I'm gonna erase this. I'll leave that up there for a bit. All right, I've got to kind of keep myself straight here. Does everyone still have that handout from last time? That was one side had the box plots, and the other side we haven't done yet. Remember that was the box plots with heights of fathers of students?
Yeah, it's all that. So.
Okay. So, we're about to get into the stuff, and then I'm going to unleash you on that other side of that handout. Let's do this. We're going to talk about measures of center. How to figure out what the center of data is. And if I just say that, if I just say, how do you get the center of a set of data? If I just say that, what is your immediate reaction in terms of what would you calculate? Do you want to know the center of the data? You would calculate the...
like the 50th percentile.
Oh, sweet, okay, I love it. Okay, this kicks so much ass. 50th percentile, makes sense. It's the number that's in the middle of all the data. But if I wanted to know like what the center of the quiz grades was, what would I calculate? The mean, otherwise known as the average. So like in everyday parlance, that's the average. But there's two, so that's why this is plural, because there's multiple ways to figure out the freaking center. So the most common way is what we call the average. To be honest, in statistics, all of these are called an average. So to be more specific, we call it the mean. So that is the word I'm going to use from now on when I'm describing what we know as the average. I'm going to call it the mean. Okay. So the mean is exactly just, what we call the average. It's, you know how to get it. So if I want to do an example, if I have this data here, 5, 6, 7, 7, 9, right? How would I figure out the mean?
Add them together, 5 by 5.
Yeah, so let's say this is a, let's just do that. So if we add them all up and divide by how many there are. Just to put it in, believe it or not, that's English, what I just wrote. Add them all up, divided by how many there are, right? That's pretty much exactly the way you would describe to somebody how to get the average. Now, I don't know if you guys remember, what did I tell you was the main thing that gets people down about this class is the amount I talk, okay, that's one thing. But the other thing is the Greek letters, right? There's some Greek variables in this class. We have to understand what they mean. Some of them aren't variables. Some of them are functions. Some of them are algorithms. Some of them are commands. Do this, right? So the most fundamental letter we're going to use in this class, you're going to see it a lot, is the Greek letter sigma. It's the Greek letter S, and we chose it because it looks neat and because it's the letter S. So the Greek letter sigma, that tells me whatever comes after that, I have to add it up. So think of this as sum up whatever comes after, right? So for no matter what list of data I've got, I don't care what the list of data is, I'm going to add up all the data values, right? I'm going to add up all the data points, yes? So I'm going to add up all of the data points. So X could represent all the data points, just like it does in algebra, it represents all the possible answers. And then we already have the letter for this. What letter do we use for how many there are in a group? N, the number of things. Okay, so here's our first official statistics formula. Okay, you guys doing okay out there? So I really want you to start to understand, mathematicians, it's our job to try to take some big freaking ideas of what to do and condense them into really quick little shorthand. And then it's everybody else's job in the world to say, what the shit is that? Oh, that's what that means. Okay, so just to catch up with that, right? Because unfortunately, or fortunately, we weren't around back then to get to say anything about it. It's like, why would you use that Greek letter shit? Or whatever you have trouble with, right? So we just have to catch up with what the hell they decided. So, of course, to do this problem is pretty straightforward, right? So when you add these up, you get 34. Holy crap. And then how many numbers are there? 5. Divided by 5 kicks ass. Double this, and then move the decimal back once. 6.8. And then, real quick, listen. If you did this work, let me ask you this. If you did the work and you got, so the actual answer is 6. Let's say you got 11.2. Obviously something went wrong. Would you circle that shit and keep going? Or why does that immediately not make any freaking sense?
It's not even with
Because it is bigger than every data point. How could that be the average? Do you guys see what I'm saying? So just take a second and go, does what I just got make sense? Don't go, calculator, tell me. No. We're the humans in this situation. We gotta go, oh, that doesn't make any damn sense. Let me do that again. And then you get your 6.8. And that makes sense because it's kind of in the middle. Coolness. Okay, maybe. So let me talk about this symbol real quick, just by itself. Just this symbol, sigma. Magma. So, let's say I gave you, so talking about, a little side note, talking about sigma. So say I give you some data. I'm going to give it to you like this. I'm going to leave this blank for the moment. Let's say I give you some data. 1, 2, 5, 7. And my question is, what is the sum of x? Well, that's pretty straightforward, yes? What's the sum of x? 15, right? What does this want me to do? And I will tell you this, that is not 15 squared.
It's the sum of all the x's.
Yes, so, okay, stay with me, this is huge. We're gonna see this freaking symbol through the whole semester. Every time you see this symbol in a formula, you cover it and you say, I need those so then I can do that to it, yes? This says sum up this stuff. Do I have that stuff yet? No. So let me go get that shit. Now I can do this, right? Because that says sum up the x squares. Well, now I have the x squares. So what's the sum of the x squares? No. Is that going to be 50, 75, 80, 79, right? Is that cool? How would I write it if I wanted to square this?
You put sum of x.
Yeah, you have to do this. Okay, right? Do you guys see the difference between this one and this one? This says square the sum of x. This says add up the x squares. Okay, I am spending some time on this for a reason. This is going to be with us the whole semester. A lot of our formula is going to have this in them.
Is the x next to segment, is it written as a subscript? Or is it going to be?
Oh, no. It's not a subscript. It's right in line. Yeah. There will be certain variables that have little subscripts on them so they can identify which thing they're talking about. But no, this is not a subscript. This is the sum of stuff. So this would be 15 squared. Right? And what's 15 squared?
125?
Close.
625?
Not quite.
225.
Yeah. All right. I like it. So can you guys, don't say anything out loud. I want you to use this data I've given you, and I want to know what this is. Right, just take a moment. And again, remember, what do? Do you have those? Do you know what those are? No. I know what x's are, I know what x squares are. Do I know what the 2x minus 1s are? No. Can you make a column and create them? Do it. Here's your x's. Right? This feels a little bit like algebra. Yes, this is the most algebraic this class is going to be. And it's one of the most basic things of algebra, an XY table. Isn't this sort of like an XY table? So when x is 1, what's 2x minus 1? 1. Twice 1 minus 1 is 1. Twice 2 minus 1. Twice 5 minus 1. Twice 7 minus 1. And now I can do this.
26.
Yeah, 26. I love it. Okay, maybe. All right. So again, when we come up with other formulas that have the sum in them, which will be today, we'll kind of run this over again. But this is going to happen this whole semester. So I just want you to realize what the hell that symbol is asking me to do. That's what all of math is. Here's a symbol. What does it want me to do? So for example, when I ask you, can anyone tell me what this is?
5.
Beautiful, right? Why is that so easy? Because we've learned this shit. It's like knowing 2 languages. When you see that symbol, you don't have to translate it because it's automatic. You with me? So if I'm like trying to speak French, I'm going to speak really slowly because I have to think each word, blah, 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 you know. Je vais à la plage. All right, sweet. Right? But here, you don't have to think about it. You totally internalize this thing. But what is the question that this thing asks you? What question does this symbol ask you?
What multiplied by itself is 5?
What multiplies by itself to be this? Do you have to actually think? Do you have to actually think that? No, because you've internalized it completely. But I want you to realize there was a process, there was a time when you didn't have it internalized. And every time you saw it, you had to think to yourself, right? So now when you see this symbol, you got to stop and think, that tells me to add up this. I don't have it yet. Let me get them, and then I can do what it wants me to do. Okay. Kick ass. That's a lot of mathematics. It's just, here's a symbol. What the hell is it asking me to do, right? Okay. I like it. Now, good Lord, we just talked about the average, and look at all this shit that we did. Okay. So, the first way to measure the center of some data is what we call the average. It's the mean, and that's one thing. The thing you came up with, Martin, is something else. It's the middle of the data. It's the 50th percentile. Is that necessarily going to be the average? No. So, for example, so we have to come up with a name for this. So let's use this. What's in the middle of the road? What runs down the middle of the road?
The median.
The median. Okay. So that's going to be, this is what we're going to call the median. Oh, by the way, oh shit, I got so hung up on the summation symbol. Before I get too far away, for the mean, the symbol for the mean, if it's a population, then we use the letter O. You're going to love this shit. You ready? All right. So it's like a U with an extra leg. It's just a U with an extra leg. And the name of it sounds like what a French cow might say. So the name of this, yeah, I just made this joke. I did. I'm sorry. The name of this is mu. 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 Okay. I don't care if you don't like it, because I like it, and that's all that matters. So the population, if it's a population, we use this symbol, and it's the same stupid formula. If it's a sample of data, we use the symbol I used over there. X bar. That's actually what we call it. Same formula, different symbols. Because if I just use a different symbol, if I just say mu is 7, you automatically know I'm talking about a population. I didn't have to say it. If I say X bar is 20, then you know I'm talking about a sample. Okay. So which one of these would be a parameter?
Yeah.
Mu, because it's describing a population, that would be a statistic. I love it. Kick ass. Okay. So I'm sorry, I just forgot to come back and talk about the 2 different kind of symbols we're going to see. So we're going to see these symbols throughout the entire semester. Okay. For the median, it gets this symbol. It's sort of like a sample mean that had a rough night. You had a rough night. So it's like the tilde on top. I'm sorry, the bar on top got mushed, so it's a little tilde now. So this is the symbol for median. X tilde. And the median is just literally the middle number, right? It's P50, it's Q2, it's the middle number. So if I use that same set of data, let's call it age. There we go. 5, 6, 7, 7, 9. What is the median? 7. That's crazy because it's the middle. Yes? Isn't that silly? So what about if I have, don't say anything out loud. Don't say anything out loud. Do not say it out loud. Okay. Think about what the median of that data would be. Don't say it out loud. One semester, it didn't matter how many times it said don't say it out loud. This one kid would be like, no, don't. Now, if you think the answer is 1, you're wrong. Because if it was 1, I could make the median anything I want, and then why would we even have it? So why was this median correct? Because the data is in order. So the median is P50. Doesn't that data have to be in order for percentiles to make sense? So the first thing you have to do to this data is put it in order. Now you can see what the median is. 4, right? Okay, kick ass. So there's median 7, there's median 4. Okay. Couple more examples because the median's not always nice, and we know that's true because it's a percentile, and percentiles aren't always nice. What about if I have this data here? What you got, Jeff? 4, 5, 6, 11. What's the median going to be? Beautiful. Right? That's exactly what we do with percentiles. This is just a little more focused. So if there's an even number of things, it's got to be the average of the 2 in the middle. So that becomes the thing in the middle of everybody. If it's an odd number of things, there's obviously one that's there's one in the middle, right? We'll split you guys off. Sure. You guys with me? So odd numbers easy. You can find an even number. You have to average the things in the middle, just like with percentiles. This is exactly what happens with percentiles. Now, when do I use the median and not the mean? So let's say this real quick. Let's say you're going to go start working at a corporation. You're going to go start working at this little business. It's a little startup business. They have 3 employees and a CEO. And you want to know what your starting pay is going to be, right? You want to get an idea of what the starting pay is. You with me? So maybe the salaries look like this. 45,000, 50,000, 52,000, 450,000. Maybe, yes? So, you know, the CEO, I don't know who it is. Okay. So, let's say you're like, okay, can you give me some rough idea of how much money I could expect to make after working there a few years? Well, what's the average of this data?
What is the average of that data? Good question.
I don't know.
It's gonna be like
597 divided by 4 is like 150, so it's 149.75 maybe?
sure.
Don't go that. Somebody have a calculator?
Let me see.
597 divided by 4, 149.25. I think that was close. I went the wrong way. Dang it. I'll retire now. I'm sorry. So if you told me, if you're one of the employees, and you're like, yeah, the average is $149,250. Is that accurate? Is that really how much I can expect to make? So the average doesn't make sense when there are outliers, right? When there are outliers, the average will be affected. Now, real quick, watch this. Look at the last example real quick. The median was 5.5, correct? What if instead of 11, the biggest number was this?
It'd still be 5.5.
The median is still 5.5, yes? The median does not give a shit about outliers because the median only cares about the middle, right? The mean includes every data point. They all get added together. So the minute one of them is really far off, the mean gets pulled in that direction. What would the median be here? Yeah, 51,000, right? These were in thousands, thankfully, not $50 a year. Yeah, $50 a year. So $51,000, and this would be $149,250. So that's no. Don't tell me that one. That's a lie, right? When we talk about home prices in San Diego, do we use the average or the median? Freaking median, right? Because if you go out to La Jolla, I like to walk by the houses that I'll never be invited into even and go, oh, look at that thing. Right? Oh, wow.
I mean, you're not going to be invited in if you just wander around outside.
Well, yeah, I do. I wander around my bullhorn and go, hey, let me in. You know, nobody lets me in. I don't understand. This would be a much more accurate description to somebody. Oh, yeah, you can expect to make around 51,000 after working here a few years. Doesn't that make sense?
Question.
Yeah.
So for the X's, the one with 149, the X has like a straight one.
This, sir?
Yeah, but
That's an average.
and then the one with the curve.
That's the median.
Okay.
Yeah, so X bar is the sample mean. X tilde is the median. And there I could have used a little mu, but you know.
Do any of the other like measures of center have different symbols for population and sample, or just mean?
Oh, well, not measures of center, but like measures of spread they do, for sure. In fact, the last two measures of center don't even have a symbol for little things. All right, so everybody got this so far? So there's mean. When do I use the mean more often? When there's no outliers. When does the median make more sense? When there are outliers. Okay, okay. Okay, so there's two more measures of center. Everything we've done so far, what type of data does it work for? And when I say that, I mean in terms of the two Qs. Truly numerical, so quantitative data. Because I can't add shit up unless it's truly numerical. So what if my data is like names of cars in the parking lot, right?
Average out the letters.
Yeah, you assign numbers to the letters, make like a cipher, and then no, right? So there's another measure of center that's called the mode. And normally you run into that word like with pie a la mode. Anybody ever heard of pie a la mode? Pie with the ice cream, right? And when you get pie a la mode, you want the one that has the most ice cream, yes? Unless you don't like ice cream, I'm sorry. You might be lactose intolerant, in which case go to Kula, up near Mira Mesa. Anyway, there's a really good non-dairy ice cream. So the mode is really the thing that occurs the most. So that doesn't have to be numerical. So if I go out to the parking lot and I see the most types of cars, that I see Ford is the most prevalent brand of car, that's the mode. So mode is the one measure of center that doesn't require numerical data. Now, does it work with numerical data? Yeah. Shit, yeah. So if I have this data, yeah, that's easy. What's the mode? 2 occurs the most. What about this data? All right, so this mode is 2. What about that data?
See? 25.
Oh, I see what you're trying to do, but no. This is what we call bimodal. 2 modes. So the modes are 2 and 3.
Oh.
I like it though. You're thinking about averaging like we have before, but this is strictly just trying to figure out what occurs the most. So in this case, those occur, they tie. Right? So what about this one? 1, 2, 2, 2, 3, 3, 5. What's the mode? Yeah, now's a clear winner, right? You see there's a clear winner, so the mode is 2. By the way, it goes up to trimodal, and then after that, we're like, there's no mode. Nobody win. So we go up to trimodal. But after that, we're like, if there's more than that, you're like, no. It's too many ties. Nobody wins. Okay. All right. And of course, what about this data? What's the mode here?
There's no.
No mode. No mode. I love it. Okay. Maybe. So we got mean, median, mode. And then there's one more. Yeah, I might as well erase. There's one more called the midrange. Remind me what the range is. It came up earlier. What's the range? High minus low. So the mid-range wants to be the number that is in the middle of the high and low. Now, let me see if you guys can do this. So if I have this data, 11, 12, 16, 19, 40, can anyone tell me what number is between exactly in the middle of 11 and 40? How would you figure that out?
You can subtract them from each other.
Yeah, that's one way you could do it.
Well, you could 40 minus 11.
Sure. Yeah, good. I like it. The more textbook method is to just average them. So if you ever want to know what number is in the middle of two numbers, just average them. So one way to do it is to do 11 plus 40 and then cut them in half. So that would be high, how did I write it? It doesn't matter. Low plus high divided by 2. That's one way to do it, right? That'll be the numbers in the middle of those two numbers. So that's 51 divided by 2, which is 25 and a half. I love it. So that would be the mid-range. Another way to do it is to say, okay, how far apart are they? And cut that in half. Right? So that'll be 14 and a half. And then you add that to 11. So if the full distance is, where am I at? Is 29. If that's the full distance, then if I go half the distance up, I'll end up at the right place. So sure enough, if I take 11 plus 14, 25, I still end up at 25 and a half. So that's kind of like the method you were talking about. Okay. So I'm just trying to get to the middle of the two numbers. That's the mid-range, middle of the range, mid-range. So now, I am finally going to shut the hell up. And I'm going to let you guys work on this. If you don't have this, let me know. This is the one where the one side was percentiles and boxplots. And the other side says, yeah, the other side's got the 4 sets of data. Group A, Group B, Group C, Group D. You're going to want a calculator. So if you don't have one, let's do that real quick. Anybody need to borrow one? Coming up. Oh yeah, all right. I know where you are. Do you have a?
I'm not social.
Oh sure.
Not just kidding.
That's funny. Thank you. Everybody else is good? Okay. So, let's see how many people I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, almost 12. Yeah? Yeah. And everybody's got this sheet, right? Everybody sees what I'm talking about. It says Math 160 Data Analysis Exercise. Holy crap. So I'm going to try to help you out. I'm going to put you in groups of 4. If you're smart about it, you can divvy up the work, right? So maybe you 4 right here, you guys, get together and divvy the work up. Let's see. Wait a minute, did I lose somebody? Or did I just get, oh, here. Okay. Let's see. Maybe you 3 here. Oh, Nico, you're these guys? You guys right here? Right? You guys? 1, 2, 3, 4. Martin, you guys right here, you 3. I don't have enough for everybody to get 4. And then You with these guys. Yes. Ryan.
Yeah.
Hey, look at me remembering shit. You four here work together and divvy the work up, right? Or don't. So come together right now. Now, if somebody's already done all the work, maybe shut up and let the other people do the work. Okay.
Yes, sir.
Thank you.